All right, let's look at the Eiffel Tower. What's cool about a lot of the problems here, they give real numbers. These are, I think, real numbers for the Eiffel Tower. Um, so it's got a mass of 7.3 million kilograms. It's a lot, right? All the steel that makes it up. They give you a number. They say that the volume, if you take all that, if you were to melt all that metal down, it would fill a volume of 930 cubic meters. You don't actually need that number for this problem. I don't know if they just put that there to make it interesting or confuse you or something. But all you need to know is the mass of all the steel is 7.3 million kilograms. So then the problem is, okay, let's say that we put the Eiffel Tower in a big cylinder. You want to box it up and ship it somewhere. Okay, you know that so you make a big cylinder box. Most of it's going to be empty, right? You got some air in there. You got some metal in there. So actually, we do have to subtract out the metal from the volume, right? So they say we want to know what all the air inside your cylinder weighs, which means we got to subtract out the volume. So in that sense, we do need to know the volume of all the metal. So the metal has a mass of that, and the volume of the metal is 930 cubic meters. 930 meters cubed. And we want to figure out what all the air inside your box weighs, so we know the shipping weight, because you're going to put the Eiffel Tower and it's going to be filled with air, and you're going to ship it off. And then the interesting thing is, does the air weigh more than the metal, right? You think, oh, you're going to need a box that's going to weigh 7.3 million kilograms, but you seal it up, the air inside, is that going to weigh even more than all that metal? And so that's an interesting question, right? And it turns out the density of air, this is real, is 1.225 kilograms per meter cubed. So if you have a box, a meter and a side, right, about a yard, a meter and a side, you have a box about this big, the air inside is going to weigh 1.225 kilograms, which is about 3 pounds. That's a lot. Air weighs something. We don't think about it, but air actually, has a reasonable mass, a reasonable density. A box this big, the air inside it, you squish it all down or something, it would weigh about 3 pounds, a little over a kilogram. It's crazy. All right, so we got to know something about cylinders. You guys have studied cylinders before. The volume of a cylinder is pi r squared h. They tell us the height of the Eiffel Tower. The height of the Eiffel Tower is 324 meters. So this height here is 324 meters. It's a square base. This is one tricky part. A square base with 125 meters per length of the square. Okay, so here's the base of the Eiffel Tower. So this is 125 meters. Right, each side is 125, but we're going to have to fit it in a circle. Okay, so we're going to have to see if I can do this well. So we're going to have to fit this thing in our cylinder. So, did touch right there. So we need to know the radius of the cylinder, right? So we're wasting some space there. So let's see. If we know, let's draw a little triangle here. So there's our radius. So we want to know the hypotenuse here. And we know each side here and here is half of that radius. Okay, does that make sense? So this side of the rectangle, let's call it S for side, and this side right here, that S is clearly half of the square. So that's 1/2 of 125 meters, which is 62.5 meters. 62.5 meters, I think that's right. So we can figure out the radius now by the Pythagorean theorem. So r squared is equal to s squared plus s squared, which is 2s squared. Take the square root of both sides. The radius, take the square root of this. The square root of s squared is s, so it's just square root of 2 times s, which is the square root of 2 times 62.5 meters. Okay, now I'm going to need a calculator. Square root of 2 times 62.5 meters is, square root of 2 times 62.5. I get 88.388. I'll stop there. 88.388 meters. 88.388 meters. Now we know the radius, we know the height, so we can calculate the volume. It's pi. Oh, looks like we just needed r squared. So I didn't need to take the square root. R squared is this, well, whatever. Is this squared here. So is times 88.388 meters squared times the height, which is 324. So let's see what that is, and it's always good to keep the number in your calculator. So let's see. That's 78.2.5 times pi times 324. 324. I get 7952156.404. 7952156.4. I'm going to stop there. 156.4. It's pretty good. That's how many meters cubed the volume of the cylinder is. Now, not all of it's air. We have the Eiffel Tower in there. So it says, suppose the tower is contained in a cylinder, find the mass of the air in the cylinder. So we got to subtract out the volume of the Eiffel Tower, which is 930. That's like nothing, right? It's practically negligible. But if we take away 930 from that, it's just going to change it a little tiny bit. We don't really even need to do this, but I'm going to anyway. Minus 930 equals 7951226. 7951226. 0.4 meters cubed. It's practically the same thing, right? 7952 to 7951226, but whatever. So that's how much air is in there. That's the volume of the air. Now we can figure out the mass because we know the density of air. So finally, and I'm running out of room, so I'm going to box out some space over here. The mass of the air is the density of the air times the volume of the air, which is 1.225 kilograms per meter cubed times this number of meter cubes, 7951226.4 meter cubes. Check and make sure meter cubes cancel out. We're left with kilograms. So finally we multiply that times 1.225 times 1.225, and we get 9740252. I'm going to round off. So it's about 97,402,000. 97,402,000 roughly. I'm going to round off to there. Kilograms. Okay, so the air weighs a little over 97 million kilograms inside our box. The Eiffel Tower only weighs 7.3 million kilograms. So the air weighs way, way more. Air weighs something. Air, you know, you think about, oh, the air hardly weighs anything, but the air actually weighs more than the Eiffel Tower. So if you were to box this up, the total mass of the thing would be this, 97 million plus 7.3 million would be over 100 million kilograms. Pretty cool. All right, so that's how you do this problem. The main ideas were the volume of a cylinder, figuring out the radius, knowing a square, so what size circle fits it, and then using the density formula to figure out the mass and making sure our units are right. The good thing is they didn't mess us up with units in this problem. Everything is meters and kilograms. It's just making sure we did all that correctly. Okay, pretty cool. Thanks for listening.